Welcome to week 4 and video number 4 on polynomial operations. First, we're going to look at adding polynomials. Add only like terms. Organize the polynomials in the easiest way you can see it, vertically or horizontally. Simplify all terms completely and totally. Make sure of the signs in front of the parentheses. Cancel out any terms if necessary. The examples below are actually subtraction because you can see the negative in between. That negative must be distributed to each term in the right-hand side parentheses. So in the first one, the more colorful one on the left-hand side, it becomes negative 3x squared, a positive x, and a negative 5. This next step is grouping the like terms and then combining them in the last step to get 2x squared plus 4x minus 11. The next example on the right-hand side, you can actually see the distributing arrows. We're distributing the negative to the 2x squared, which gives us negative 2x squared. Distribute the negative to the negative x, and a positive 2. Now we're going to combine like terms, and we get x squared. 3x plus positive x gives me 4x, and 5 plus 2 gives me 7. This is an example of subtracting horizontally. Remember, subtraction is just the inverse of addition. Notice the distribution of the sign to the variables. Next, we're going to multiply exponents. Choose to set up the polynomials either horizontally or vertically. Keep in mind of the signs in front of the variables. When multiplying the variables that contain an exponent, instead of multiplying them together, add them instead. That you should remember from week 1 in your rules of exponents. Always distribute any number, sign, or variable in front of the parentheses. In the example below here, we have 3x squared, a monomial, times a binomial. The binomial is x plus 5. 3x squared must be distributed to x, which gives us 3x to the third. 3x squared distributed to the 5 gives us 15x. Next, we're going to divide polynomials, and we're going to start you off with an easy one. We'll start off with a polynomial divided by a monomial. We can take each piece individually. So if we take that left-hand side, we'd get 6r squared s squared divided by 3rs, and you can see we can do the same with each 3 pieces. When we're ready to now do the division, in the red part, the 3 cancels into the 6 and leaves us with a 2, r to the second power over r to the first. The rules of exponents tell us we can subtract. That gives us r to the first. The same with the s's, gives us s. In the blue section, the 3's cancel, the r's cancel, and again, the rules of exponents say we subtract the exponents when we divide like bases, which leaves us with just s. In the last step, don't forget to bring down the negative, because it's minus. The 3 goes into the 9 3 times. R goes into r squared r times, and the s's cancel. Next, just when you thought you were done with long division, we're going to bring it back. We're going to divide the trinomial x squared minus 5x minus 24 by x plus 3. The x squared goes underneath the division sign and is called the dividend. The x plus 3 goes in front of the division sign, and that's called the divisor. The answer that we get is going to be the quotient. Our first step is to divide the first term, x squared, by x in the divisor, which gives us x. We place that x up in the quotient space above. Next, we multiply x times the divisor, and that gives us x squared plus 3x. Keeping in mind that we must subtract when we do long division, that gives us negative 8x. The next step is to take the negative 24 and bring it down into our answer here. Then we're going to take negative 8x and divide by x, and that gives us negative 8. That negative 8 goes up into the quotient. Next, we multiply negative 8 times our divisor. That gives us negative 8x minus 24. Keeping in mind again that we must subtract, that gives us 0. The answer for this problem then is our quotient x minus 8. Remember, if you want to check this problem, you would take the divisor, x plus 3, multiply it by the quotient, x minus 8, and you would get the dividend, x squared minus 5x minus 24. The next long division is just a little bit harder. It has a remainder with it. Not only that, but if you look at the original polynomial, it's x cubed minus 11x plus 28 divided by x minus 4. In order for us to do long division, we must have a variable of each exponent in descending order. Therefore, we must put a placeholder in our dividend of 0h squared. So our first step is to take x to the third power divided by h. That gives us h squared. That h squared goes in our quotient above the second term. Then we multiply the h squared by our divisor, h minus 4. And that gives us h to the third power minus 4h squared because we distributed the h squared. Keeping in mind that we are subtracting because this is long division, that gives us 4h squared, then we bring down the negative 11h. Next we take the 4h squared divided by h in our divisor again, and that gives us 4h. That 4h goes up into the quotient. Next we multiply 4h times our divisor h minus 4. That gives us 4h squared minus 16h. Keeping in mind that we must subtract, that gives us 5h. We bring down the 28. Our next step is to take 5h divided by h. That gives us 5. We put that 5 up in the quotient. Then we multiply 5 times our divisor. Gives us 5h minus 20. Keeping in mind that we must subtract, that leaves us a remainder, in this case, of 48. Now, we write our remainders just a little bit different. In the quotient, you'll see we write it as plus 48 over h minus 4, our divisor. Our answer is the quotient h squared plus 4h plus 5 plus 48 over h minus 4. I hope you enjoyed this video. It's always a pleasure trying to make these. Have a good week.